Imagine feeling an itch on a foot that is no longer there, or sensing the warmth of a hand that has been amputated. This is not just imagination. It is a very real experience for many people, and it is a powerful example of how our brains construct our reality. When someone experiences phantom limb sensation, it is because their brain is undergoing a fascinating process of reorganization. Specifically, the brain areas that were once responsible for processing sensory information from the missing limb become active in new ways. The brain still expects input from that limb, and when it does not receive it, it adapts. The core reason for this lies in the brain's incredible plasticity, its ability to change and rewire itself. After a limb is lost, the section of the somatosensory cortex, which is the brain's main sensory processing hub, that previously handled signals from that limb no longer receives input. Rather than staying dormant, neighboring brain regions, such as those corresponding to the face or torso, can actually encroach upon and take over this unused territory. So, a touch on the cheek might be interpreted by the brain as a sensation in the missing hand, because the neural pathways have been remapped. Understanding this brain remapping helps medical professionals develop targeted interventions to alleviate discomfort. For instance, therapies often focus on helping the brain reconcile the missing limb with its internal body map. One approach involves engaging the brain in ways that provide it with new, coherent feedback, helping to reduce the brain's internal confusion about the body's new state. This can significantly improve a person's quality of life. A particularly clever technique is mirror therapy. This involves using a mirror to create a visual illusion of the missing limb, making it appear as though the limb is still present and moving. By observing the reflection of their intact limb, the brain receives visual feedback that can trick it into believing the phantom limb is moving or performing an action. This can help to alleviate sensations like clenching or cramping, which are common in phantom limbs, by providing a sense of releases. Ultimately, the phenomenon of phantom limb sensation powerfully demonstrates the brain's extraordinary adaptability and its continuous effort to create a consistent representation of our body and the world. It reveals that our sensory experiences are not just direct readouts from our body parts, but rather complex constructions orchestrated by the brain, capable of reconfiguring itself in the face of profound change.